Part 3. Here is your typical geyser. Keep in mind what's going on underground. Water is dissolving a lot of minerals, shooting them up. Those minerals eventually may cement sand together and help create sandstone. Here again is the material called geyserite. It usually contains a lot of calcium carbonate, magnesium carbonate, and even silica, the stuff that makes quartz. A lot of times it will have sulfur in it too. Sulfur in the old days was called brimstone. You find it on the brim of volcanoes. And the ancient people associated with hell because, well, it was hot, it was coming out of the ground. So they talk about brimstone being associated with this kind of activity. Near volcanoes, you usually find sulfur. Okay, they're just plain stinky to be honest with you, but it's kind of cool. When you can get water that's coming out of the ground and you can control it in steam, because steam expands about 1,500 times over what it took space-wise as water, you can use that steam to drive fan blades around. You can attach those fan blades to magnets. Those magnets can go inside a bunch of wires and you can create electrical current. In this case, instead of burning coal or having water behind a dam, you have steam from hot water under the ground creating free electricity. Creating geothermal plants like this is a great idea if you don't want to be burning coal and putting mercury into our waters, our lungs, our children, and our air. The only problem is setting up the plant tends to be expensive up front, but after that, your fuel is free. This is being done in New Zealand. These are the geysers in California. It's being done in the Philippines. You don't want to take the heat out too fast because you can actually reduce your heat source to the point you no longer get free electricity. But this is a viable alternative. Researchers at Los Alamos National Laboratory developed what was called the Hot Dry Rock Project, where you drill down into the earth quite a ways, you inject water, the water comes back out as steam, and that steam generates, well, free electricity. Again, the plant is expensive, but the technology works. The research was done, it was submitted, and then the funding was cut for the project. Take a look at Los Alamos National Laboratory Hot Dry Rock Project if you're interested in reading more about it. It's one of my web pages. Here is a look of a geothermal plant, geo-earth thermal heat from the air. Now let's talk about caverns and weird word karst topography. Caverns in Arizona. Karstner Caverns is down here. Here's Dinosaur Caverns. We've also got Colossal Cave down here. Here's what Karstner Caverns looks like. What's going on here? How do you get these things? Well, it's not just Arizona. These things occur all over the United States. Much more back here and a little bit less here. These, by the way, the yellow ones are volcanic caves. The yellow or the aqua ones are limestone. Here's what's going on. Water going down through limestone, and in particular it has to be limestone, begins to wear away at the limestone. It creates little fractures and then larger fractures and larger fractures, and eventually the water goes out, leaving behind, when the water table drops, these openings called caverns. The water coming down contains a lot of calcium carbonate, CaCO3, so when the water reaches this opening after the water table is dropped, the water will begin to drip. Some of the drips evaporate, leaving behind calcium carbonate bit by bit, building up these icicles called stalactites. Stalactites hang from the ceiling, C-E-I-L-I-N-G, stalactites. Underneath the stalactites, sometimes the water drips and evaporates, leaving behind the calcium carbonate, like the calcium carbonate around the faucet on your sink, and you end up with stalagmites. These grow on the ground. G for ground, G-R-O-U-N-D. Sometimes these join together and you end up with columns. Could this be a cavern? Possibly. This is a guy looking down into an area of karst topography or limestone topography where rainwater over centuries has dissolved the rock. These are typical features in an area with limestone. You find collapses or sinks. What's happened here? That's an area over a cavern that has actually fallen in. There are sinkholes. You can go in these, but you never know if you're going to get out. So don't ever go caving on your own, and make sure you know what you're doing. Streams often disappear in areas with limestone because they're going down into the caves, and then they'll come back out eventually. Does this kind of stuff really happen? Well, yeah. This is in Venezuela. This is an area where caverns have collapsed. These are huge. This was an area that was out of the water at one time. Since this time, this area has dropped underneath the ocean, and this is the Great Blue Hole off of Belize. Here's the Devil's Sinkhole. It was a limestone dig near Hawthorne, Florida. People like to swing off here. Notice that the limestone tends to make the water kind of, what would you call that, turquoise? Just like in Havasu Canyon in northern Arizona. And here, Montezuma's Well, a collapsed area. There are some really rare species in there, and you'd think this would be great to drink, but there's a problem. When water goes through the ground, it dissolves materials that are, well, in the rock. And in this case, these rocks contain a lot of arsenic. So you probably don't want to drink this stuff or to fertilize your crops with it or water your crops with it. Early pioneers did. I have no idea if it affected their health, but I suspect it did. Here's the north rim of the Grand Canyon, Highway 67 leading into the north rim. And if we zoom in, you see things like this. Crane Lake, it is a collapse feature over a cavern. The north rim of the Grand Canyon is largely limestone, so it's karst topography. You find very few rivers there, and those that you find disappear. Here is an area southeast of Winslow where there are collapses. I've always wanted to visit these, and I have yet to do it. Here is really cool karst topography with a little cattle fence between these. Hopefully the cows know not to go in there. And here are some records. You can pause this slideshow if you want, but I don't want to spend too much time here. Just know that there are some really big caves. I believe the largest cave system, here we go, is Mammoth Cave in Kentucky. 367 miles in length. Passages wander all over. And Jewel Cave, only 140 miles. This Mammoth Cave is huge in comparison to anything else that exists, that we know of anyway. Here are some stalactites, stalagmites, and a column. Again, the water dripping down will evaporate, leaving behind the calcium carbonate, sometimes the sulfate. There are other kinds of caves or caverns, and these are lava tubes. Not the same thing, but still kind of cool. Some formations that are left behind by groundwater. Here's some concretions. Weird, but when water has minerals in it, the minerals will cement little grains of material together, and you get these strange shapes. Water evaporating from a hollow, if it contains a lot of silicon dioxide, SiO2, or quartz, as water leaves behind, it creates these concentric rings, and then the final water leaving behind, if it contains silica and a little bit of manganese, will create what's called amethyst. It's kind of like quartz, it's just stained, like adding a little bit of grape Kool-Aid to water. This is a formation from groundwater. Trees died, they got covered very quickly so they couldn't rot. Water coming down through the ground that contained a lot of silica, quartz, essentially what glass is made out of. Over centuries replaced cell by cell the rotting wood. And now we have agate or quartz in the place of the wood. This of course occurs in northern Arizona to the east of Winslow near Holbrook. Some issues with groundwater. We already talked about this. Landfills create a product called leachate. The material will leach out of here. That contains toxic materials. That will pollute your groundwater. And you'll have this plume downstream. Here is the old Motorola facility operating in Tempe back in the 50s, 60s, and 70s. Not knowing any better, they tell us, they put their TCE out on the ground and let it soak in. Well, sadly, it has polluted all the groundwater in this area. This is the green belt in Scottsdale. What we're trying to do is pump out the water, treat it, and then re-inject it. It is going to be a many decades long problem. Remember down by Eloy I showed you that the ground was sinking? Well, you end up with these subsidence fractures. This is only 6 years ago. And farmers have been known to take their old pesticide barrels and dump them into here. Yeah, that really is stupid. And here we go in Tucson. Collapses of 3 inches to 4 inches, 2 inches to 3 inches. Doesn't sound like a big deal, but if your house is collapsing that much on one side and not the other, it kind of destroys your house. Love Canal was a place where people just left materials out on the surface, soaked into the ground. Lots of deaths, lots of cancers, leukemias, things like that. Here is a cool thing. When hot groundwater goes into the ground, if it dissolves or suspends some clay in it and comes back up, you get these things called paint pots. It's actually clay, almost like tempera paint, and hot water. I was in the Philippines hiking around and I found one of these, and I was curious. It was really hot, so being stupid, I stuck my finger in. Yes, it's hot. Don't do that. Well, do it if you want, but you're going to end up with really one hot finger. Here's a typical geyser type formation. Here are more paint pots. And here's the leaky underground storage tank problem, where gasoline tanks were leaking into the groundwater. And this is what people like to do with their trash. They just throw it out because, well, you know, it's away. It'll never come back to haunt me. Big lesson that I've learned in life. There is no away. Everything will come back to you. The mafia even has been known to take barrels of toxic chemicals and just dump them. They get paid for it, and then they just dump them, and you and I have to pay for it. This is in Winter Park, Florida. This was a swimming pool. Underneath here, without anybody knowing it, was a large cavern formation. It was held up because there was a lot of groundwater in it. But as Winter Park, Florida grew and they started watering all the citrus in the area, as you recall, agriculture is one of the biggest uses of groundwater, this cavern area collapsed. Now the swimming pool is a little bit bigger, and whatever was here is gone. If you've ever taken out old pipes from a house, you know that hard water, water that contains a lot of minerals, will coat the inside of the pipes. That hard water quite often is good for you because we need calcium carbonate. It's good for our bones. But this is what happens to the pipes. It doesn't happen to your aorta. Not the same thing. Your body needs it. A lot of people stick in water softeners to keep this from happening and to keep all that white stuff from being on your shower or your sink. It does work. And this is just a pretty picture. That's it. Thanks for watching.